let's go back to a topic you had alluded to earlier, that this idea of complexity arising from simple rules that got you fascinated and sent you down this path. So let's formally define that as well. What is cellular automata?
So cellular automata are just a particular kind of computational system that are convenient because you can make nice pictures of them. And it's very important, actually, because we have certain ways to get intuition, and pictures are an important source of intuition. But so a typical cellular automaton, you have take a piece of paper, you divide it into a bunch of squares. You look at the top line on that of squares. Each square is either black or white. Yep. You fill them all in, and then you have a certain rule that says to fill in the next square down the page, you look at the square above it and to its left and right, for example, and you say, what's the configuration of black and white squares in that triple of squares? Yep. And then you just have a rule that says let's say if it's 1, 1, 0 or black, black, white, then the next cell will be a 1, a black cell, etc. You just apply rules like that. The thing that was incredibly surprising to me, is you have rules like that. You start off with just, let's say, one black cell at the beginning. You get this very complicated pattern. And that pattern looks, if you were to just be presented with some piece of that pattern, you would immediately just say, this is random. But it's not. It's made by this definite set of rules. Every time you make it, it's the exact same thing. It is a kind of an irreducible piece of computation that makes it. And to us, it is this thing that seems to us to not come from rules. We can't tell that it comes from rules, but we can produce it from rules. But when we are presented with it, our kind of ability to analyze things is not good enough to say, oh, this comes from these rules. To us, it looks just random.